Hello everyone, I am Tanmay and in today's tutorial I will be explaining how to use the container profiler for benchmarking your own specific container which you can create from your own custom built image. The container profiler is a tool to benchmark your containerized workflow application or script which you can invoke using a particular container created using the scripts provided here, and then the samples of the metric usage are collected as JSON files, and then they can be analyzed for making more informed decision whether you're trying to deploy your stuff on cloud or whether you're trying to run it locally and trying to optimize it. In all those cases, this tool is helpful. So the first thing you need to do to use the container profiler is to clone it. So this command clones it. Takes a little bit to clone, but trust me, it's not that big. So the container profiler has been cloned, and as you can see, we have these folders inside the container profiler. The ones of the primary importance are the graphing folder, the profiler bash, the profiler Python, and utilities. The profiler bash and the profiler Python are the ones which contain the build and run scripts for building custom images and running those images or the images pulled from online sources. And the bash version, the profiler bash version, is actually the legacy version of the container profiler, which was written completely in bash. The newer version, the profiler Python version, has been written partly in bash and partly in Python. And this is a newer version which is a little bit faster than the bash version, and it is also safe from race conditions, which is a small problem in the bash profilers. But both of them have been put here and made available, so you can use anyone depending on your need. For the sake of their demo today, I'll demo the Python version of the profiler because that is the recommended one. So to use them, you should go in the respective version directory. So in the Python version directory, you have two possible environments: the Alpine environment and the Ubuntu environment, and you can choose to run which one you want to. Ubuntu is slightly heavier than the Alpine version, but it is more standard. And Alpine, on the other hand, is a lightweight Linux distro, which is not that standard, but it's very lightweight. So depending on your need, you can choose which environment to run the profiler into. It is important to note that the profiler bash version, which is also which also has the same structure as the profiler Python. It also has the Alpine and the Ubuntu versions which run the bash version of the scripts, so you can use them too if you need. And there is a total of 4 possible types of environment version pairs that you can create. So for this demo, I am going to use the Alpine version. To use that, I'm just going to go in the Alpine directory. Before we do that, I'll just quickly point out that in the source directory, which is also common in both the profiler and the bash and the profiler Python version, the source directory contains the common files between the Alpine and the Ubuntu versions. So in this case, the profiler, this is the entry point of the containers that you'll be creating, and the rdata all psutil.py is the Python script which is actually getting the JSON samples and storing them inside the specified output directories. So let's go in the Alpine version. So now inside the Alpine version, you will see there is a bunch of different files. The first thing you should do to build your own custom image is to open and modify the build.cfg, which is a config file. So let's go and modify it. As you can see, there is a total of 3 parameters here. The first thing is whether you want to check for an online version of the image, and if you're checking online, which tag you want to put and which tag you want to check for, which image you want to check for, is something that you put here. The checking or not can be basically controlled by a Y or N. For this demo, I'm not gonna check online and build the images from the source locally. So I just need to put an N here, and since I'm building the image locally, I should give it a tag. The TAP tab is the tag I'm giving you. It's a random tag, you can say, and you can assign your own tag to your images. So this tag is going to be put on the image to be built, and I don't want to save anything here. The next thing to do is to modify the Docker file. The Docker file is the main file which is going to create your image for benchmarking your containers. So as you can see, I have the Alpine 3.11.3 version here. It's copying a bunch of things, and it's installing a bunch of base packages. Inside here, I have added this particular line, apk add stress ng. Now, typically you should be adding all of them at the base here. So something like run apk add stress ng, just so that you don't end up modifying anything on the top. And as you can see, we have the stress ng package being installed here, because that is what we're gonna use to stress it. Now, stressing the CPU takes a little bit of time, so I'm just writing the stress ng command for a demo, but I'm actually gonna enter a sleep command to show you how things work, because the stress ng command is gonna take like 5 to 10 minutes to run, because it stresses the CPU so much. And this video is meant to be short, so we've just saved it, and since a Docker file has been executed, it has been modified, we can move to the build script, which can be invoked using a bash command. It's important to note that in the process of creating your own custom containers, you can add as many packages as you want here using like the run commands. So for the Ubuntu, you'll have the apt repository, apt install commands to install all your dependencies. In the Alpine versions, you'll have apk, and sometimes the packages available via the apt or apk are dependent on which version of Alpine or Ubuntu you're using. So yeah, feel free to change the versions here and add the run scripts according to your own specific needs. So once the Docker file has been modified to install all the required packages to execute your workflow or a script or application which is containerized, we can move to the build scripts, and the build scripts can be invoked with this command. So the build environment, the environment name, the version name, sampler.sh. And before we build, yeah, I was just about to forget that. Before we build, we also need to keep a little bit of attention here, the run commands.sh file. This file basically gets copied whenever you're building from the Docker file. Whenever you're building your image, the run commands.sh kind of gets copied over. And many a times, if you have a fixed set of commands to be executed in your particular container, then you can use that file. So if you look in this, I've just put a simple sleep command, but between these you can put any command you want to execute and benchmark. But when you have a fixed set of commands which do not need to be altered in your particular container, you can write those commands in this particular file, say somewhere here, and this file will get copied over in your Docker image that you'll be building, and when running, we can directly invoke a command to execute the run command.sh file, which has a set of commands to be executed, and that will just execute it and benchmark them. But in case you need to keep changing your commands, and you need to keep changing things in your commands too, you can do that in the run.config file, which we'll talk about later. But for now, let's quickly build the image. So here it's going to take a couple of minutes to build. Alright, yep. So we finally have the Alpine Python container build, custom one, and we can also check that using Docker images tag. So as you can see, the tap image has been built. Now once that image is built, the next thing to do is to execute the run config file to modify the runtime parameters. So the first parameter here is the command to run. In some cases, when you have a fixed set of commands and you're adding them into run commands file, you can just execute this particular command, which will do the job for you. But in case you need to keep modifying your commands and you need to run like a different command every time you invoke your container, then you can just input your one line command here and that will do the job. So if I want to run say sleep 10, I can do that here and that will do the job. But since I've already put the sleep 10 in the run command.sh file and build it, yeah, I'm just going to keep it that way. The delta can be specified here, and the delta is basically the time interval between each of the samples. And you can provide like an integer value here. Try to avoid any fractional values or any values lower than 1 second, because that can lead into errors, because the profiler itself has a little bit of overhead, and for best results it's good to keep it between 1 second or higher. Yeah, just needs to be greater than or equal to 1 second. The next parameter is the output directory, and this is the directory which is gonna store all the samples collected. This is the thing that's gonna get mapped with the profiler output directory, and this is the profiler output directory is the one which is storing all the collected samples inside the container. So yeah, both of them can be modified if you're not happy with the C profiles, or if you're using it for some other purpose, you can modify it, and you can also modify the output directory. And this is gonna kind of volume map all the collected samples on your own host system. And the next thing is the run image tag. This is very important. This tag determines which image is used to create the container, to benchmark the workflow or do something else. But in our case, we tag the image with the tag of DAP, and that's what I'm putting here. The verbosity is again the level of detail that you need in your collected samples. So you can choose between like the V, which is like the VM level only, the C, the container level only, and the P is the process level. In my case, it was just V level before, but I guess I'm just gonna put it in a VCP level, so you have all three levels of verbosity collected. And I'm just gonna save that, and now we can finally invoke the run scripts to execute the container and collect the benchmark samples. The command to do that is run the environment, the version sampler.sh. So you can Into that, and it's gonna try to find if the image already exists. If not, then it's gonna try to build that image itself. But since we already built that image, it exists, and it's gonna run. It basically ran the sleep 10 command, which was put in the run command.sh. Although you can always provide a different command in like the run config file. You can just provide your own one-line command here and not use the run command.sh if you need to keep changing the commands that you're benchmarking. So once the container kind of executes, it creates this new JSON directory here, which houses all the collected samples. So as you can see, there is 10 samples because we had the sleep 10 command, which was going to sleep for 10 seconds, and the delta was 1 second, so it was going to collect the sample for every 1 second. So now that this is done, what we can do is create a graph using this. So the first method to create the graph is go in the graphing directory and plot this. So you can just go and visit the graphing directories, and inside that you have the graphwall.json file, which is going to help you graph these things. So this is the command that you need to invoke to graph them, and that's also provided in the under the graphing documentation. So Python 3 graphall.py -f for the file flag, and then you can go back in the profiler Python version, the Alpine, and new JSON, because that is where my generated file is. You can enter like the output directory path in the run config file and put it anywhere, but remember, to graph anything, you need to be inside the graphing directory and invoke this command from within the graphing directory, and also provide the correct relative path from the graphing directory to the place where your all the collected samples are. So if I just press enter, that's gonna create a graph of all of those things, and it's gonna store all of them in the VM container images folder. So if you go VM container images folder, it's gonna have a bunch of PNG plots generated, and since plots are supposed to be viewed visually, you can go in here and check what has been done. So yeah, you have all the plots kind of generated here, and you can analyze them. Since the sleep command was a fairly simple one, you don't see a lot of activity here, but you can benchmark your own workflows or scripts, and you'll you'll find these things helpful to kind of get an idea of how your application or a script is performing inside the container, and make more informed decisions. So yeah, that's one way of using the graphing scripts. Another way is to use the pre-built Docker image for graphing, and more information is there about that on the graphing documentation, and another video has also been created to assist you in doing that. So feel free to go there, check it out, and try it out as well. And with that, the demo of the container profiler ends here. Thank you so much for all your time, and have a great day.